Hey guys, the objective of this video is to do an abrupt change, a two-way drainage, and we're going to make beta not equal to half. So in terms of our flowchart, we're looking at an abrupt change, beta is not equal to a half, and we're doing two-way drainage, so we're down here. Now, we've been given pretty much the same case we've been seeing before, 8 meters of soil profile, a sudden increase of 100 kPa, but our CV is now 1 meter squared per year. So if we were to use the same values before, we know beta equals CV change in T and change in Z squared. So CV is 1 if we want an increment of time of 1 year, and a change in Z of 2 meters, so that would be 2 squared. This would be 1 on 4, which is not equal to a half, and this also needs to be less than or equal to a half. So that is less than or equal to a half, and that means we can do it. Now, I would not recommend doing it this way. Once again, it's always much easier to use beta equals a half. So setting these values such that beta equals a half. So you'd want to find a change in T and a change in Z for this new case such that you still get a half, because it's much easier. But we're going to do it just to show you how it's done if beta does not equal a half for some reason. So we're still dividing our layer up in increments of 2 meters. So we're going to come and draw up our table as we always do. So we have time, the stress, the change in stress, Z equals 0, Z equals 2, Z equals 4, Z equals 6, and Z equals 8. We would look at time year 0, we would look at year 1, we would look at year 2, year 3, and let's do year 4. Okay, so we rule this off. Now, we would once again find the load at any point. So at any point, at any time, our load is always 100 kPa. So this is all 100. Just like before, the change in load is 0 everywhere, except at time 0, a point just before time 0 was 0, and a point just after time 0 was 100. So we're getting an abrupt change of 100, but at any other time, there's no change in load from year to year. We would then rule this off.